Hello and welcome. In this video I will show you how to create a power system model in IRENA FlexTool starting from an existing energy system model in OSeMOSYS SAND interface. The material used for this exercise can be found in this and other repository. The link to the repository is provided in the video description. First, let's go through the contents of the repository. We have this PDF file which serves as the guide throughout the exercise. We have the Hands-on 8 folder which contains all the material from the OSeMOSYS Hands-on 8 exercise of the OSeMOSYS and FlexTool course, the FlexTool input template which we will use and populate, this Excel file containing some additional data we will need for preparing our FlexTool model, and finally the solution of the exercise, so the FlexTool input template filled in with data. Let's open the exercise guide and start building our FlexTool model. We will start from the OSeMOSYS model you already prepared and implement it in the Hands-on 8 exercise. This diagram right here shows the structure of this OSeMOSYS model, and the blue box contains the items which we shall include in our FlexTool model. These items are power plants and the energy carriers or fuels they consume, and the setup of this item is already prepared for you in the FlexTool input template accompanying the exercise. For simplicity, the names of the power plants and the fuels are the same as in the OSeMOSYS SAND interface. Going quickly over the different tabs of the FlexTool input template, we can see how the fuels and power plants are already defined for you. What we need to do is fill in the data missing. This data will mostly come from the OSeMOSYS input and output files, and only for a couple of parameters we will need to use data from the additional file. We will start the data transfer from the OSeMOSYS input SAND interface, then use the data from the OSeMOSYS outputs, and we will finally copy and paste the values in the provided data prep file to finish our FlexTool model. So let's start filling the input file. We will go about it tab by tab. We can skip the first tabs, Info, Master and Node Group, and go directly to Grid Node, where we will be able to find in the OSeMOSYS SAND interface the parameters which are necessary to fill the demand and capacity margin boxes. So I will now open the OSeMOSYS SAND interface and try to find the parameters we need. For the electricity demand, we need to filter and find the parameter specified annual demand for this commodity, which is the electricity commodity in the OSeMOSYS model. I will use the values for the year 2015, but you can use any year you want, as long as you make sure you take the values from the same year for all the parameters across the entire model. Now, copying this very value is not enough, because OSeMOSYS and FlexTool use different units for expressing the electricity demand. In OSeMOSYS, electricity demand is expressed in petajoule, whereas in FlexTool it is in megawatt hours. In the guide, such conversions are explicitly mentioned. So for the demand, we need to multiply the OSeMOSYS value with this figure right here. This is what I'm going to do. So I have the OSeMOSYS value and I will multiply it with this value right here. So now I have filled in the FlexTool demand in megawatt hours. Next, we will fill in the capacity margin parameter in FlexTool. As seen here in the guide, the capacity margin is a function of the already defined FlexTool demand and the reserve margin parameter of OSeMOSYS. So, if I open the OSeMOSYS SAND interface and find the reserve margin parameter, I can see that this is equal to 1.15. So 1.15 minus 1 equals 0.15 times the FlexTool demand divided by the hours of the year, 8760. So I will now fill in these values exactly as instructed in the guide. And now I'm done with the grid node tab. So I will now jump to the next one, the fuel tab. You can already see the fuels defined. And what we will need to do here is fill in the fuel price and the CO2 content for each fuel. This information is already existing in the OSeMOSYS interface. So I will reopen the interface and I will look for the variable cost and the emission activity ratio under the parameters, and I will filter only the mining and import technologies of the different fuels. These are likely at the top, so I can select them quite quickly, as you can see right here. So these are the technologies I need to tick. And now I have a much clearer picture of the parameters and the technologies right here in the OSeMOSYS interface. For the fuel price, I will need to scroll down to find the variable cost parameter. We can see that we have different numbers, different variable costs for the different mining and importing technologies for the different fuels. If I take the example of coal, I have both mining and importing technologies for coal. For this reason, I will need to average out the value of these two, which is 3.3 and 4.9. So if I go to FlexTool and type average 3.3 and 4.9, I will take this result. However, this is not enough, because remember that we need always to check the guide to see if there is a unit conversion involved. In this case, I need to multiply by 3.6 to align the costs in FlexTool units. So here is now the fuel price for coal. You can do the same for all fuels, and in case that for some fuels, for example for biomass or maybe for uranium, you see that there is only a mining technology and no importing technology, you will just use the value of the mining technology. You don't need to average out anything. Next, we need to fill in the CO2 emission ratio, which in this case should be the emission activity ratio for the emission ME CO2. Because the values for the importing and the mining technologies are equal, we can just use the ones for the mining technologies. In this case for coal, this is 94.6, but we need to multiply by 3.6 and divide by 1000 to align it to the FlexTool units. So 94.6 times 3.6 divided by 1000, and we have filled in the values for the coal fuel. You can do the same for all fuels. We next jump to the unit type tab, where we can see the different types of units, the different types of power plants already defined. Some of the parameters of the power plants, mainly the flexibility parameters and some cost parameters, are already defined for you. So what we need to do is to fill in the missing parameters for the different power plants. I will present you with the example for the first unit, the power bio or biomass power plant, and then you can replicate the same process for all units. So I will check and go step by step based on the exercise guide to see which parameters should be filled in and which are the corresponding parameters in the OSeMOSYS SAND file. So I will start with the O&M cost, which represents the variable operation maintenance cost for each unit, and this corresponds to the variable cost parameter in the SAND file. So if I open the SAND file, I have already filtered out for the technology I'm interested in, and I will look now for the parameter variable cost. This is right here, very low, and the value is 0.0001. I will copy this and paste it right here, but I remember that I need to check if there is a conversion involved, and there is actually a conversion involved. So what I will do, I will multiply with 3.6. Then for the availability, which is in column H, I will need to check the availability factor or capacity factor. The availability factor is for the solar, wind and hydro plants, which is power heat, power sol and power W&D, but I'm not interested in this, so I'm interested in the power bio, and for this I will take the capacity factor value. This is located probably somewhere on the top. I see that it is constant over the time slices, so any of these values is working, so I will copy and paste directly. Then I want to fill in the max reserve parameter in FlexTool, which is right here in column I, and this corresponds to the exact value, so again no conversion involved, of the reserve margin tag technology parameter from the SAND interface. This is right here and it is equal to 1, so I will just fill in the value 1. Then it's time to proceed with the fixed and investment cost. These are pretty much the same units and the same parameters in OSeMOSYS. So I will look for it right here, going up. So I found already the fixed cost is equal to 75. I will just copy and paste as the units are the same. And then here is the capital cost, which is the investment costs, called INV cost in FlexTool. And I will copy paste this again since there is no conversion involved. Moving forward, I will need to fill in the lifetime. This is located a bit further here on the right, and I will need to find the operational life parameter in the SAND file. This is located a bit lower right here, and it is time independent and equal to 30. Also for the discount rate, here it's already filled in with 0.07, but we could find the discount rate parameter for the entire model, not just this particular technology, in the SAND file. In this case, in this example, we will skip this, and we will move forward with the efficiency, which is the very first parameter in column B. And for this we need to do some calculation. We need to divide the output activity ratio of the unit in OSeMOSYS with the input activity ratio. Specifically, I will need to go and find the input activity ratio for this technology, and it is 2.86 for the bio commodity. This means that we have 2.86 units of this commodity as an input in the technology, and as an output we take right here 1 unit of the electricity technology. So the efficiency is 1 unit of electricity divided by 2.86 units of fuel, and we end up with this neat 35% value. So now we have filled in the template for the unit type sheet for our first unit, and we can do the same for the rest of the units with following the same approach. Now we have filled in all the parameters we wanted in the unit type sheet for the power bio unit, and we are ready to move forward, and we will jump directly to the unit sheet. Here we can see that only the structure is built already. Namely, we can see that we have all the unit types of the technologies, their corresponding fuels or capacity factor profiles, and the output grid / output node. Additionally, I have already filled in for you the max invest value in a very, very high number, so that it is practically unbounded. And the only thing that we will fill in here, the only parameter we will fill in here is the capacity parameter, the existing capacity parameter. Now, the existing capacity parameter for the year of interest is in any case an output of OSeMOSYS. So we will need to search for this in the OSeMOSYS output file. Let me open it for you. It is this results template, which should look familiar from the previous exercises, and this total capacity annual sheet shows us the total capacity per type of plant. I have filtered on to have to see only the power plants, and it is expressed in gigawatts. So we'll need to be careful because there is again some unit conversion involved. So we need to take the values from here and multiply them with 1000 to have megawatts, which is a capacity unit in FlexTool. So I will fill in just a few of them for the example, and then you can proceed and fill in the rest using the same process. I will again make sure that I'm using the same year as I used from the input file, from the OSeMOSYS input file, and this was 2015. So starting from the power bio, I see I have a 0.09 value for 2015, and I will need to multiply it by 1000, and I will end up with 90 megawatts. Then for the coal power plant, there is no capacity, so I will just set the capacity to 0. And then for the geothermal power plant, I have 0.655 or 655 megawatts. For the hydro plant, I can see it's 499, and so on. You can fill in the rest of the capacities right here. So more or less we now have finished all the data transfer from the OSeMOSYS input and output files, and the only thing we will need to do is to fill in also the few data that will need to be inserted externally. So I will now open this data file, which I can see has the capacity factors and demand profiles. The time series in FlexTool is some kind of data that you will always need to source externally because they are expressed in 8760 time steps, so they are expressed over the entire year, while in OSeMOSYS they are expressed over selected time steps. So you will never have the same time series in the two models, so you will always need to source them externally. So I will start with the capacity factors, which are located in this TS_CF, which is short for time series capacity factors, and I will copy paste the values of these exactly here. And then I will also apply the demand profile by copy pasting the values, and like this my FlexTool model is now ready.